Students, this is the class for 10th standard science subject, and physics our first lesson is laws of motion. Okay, in last class we have seen the principle of moments, then the derivations of Newton's second law. Okay, so in that Newton's derivation of Newton's second law, to continue that, now we are going to see about the definition of Newton. Okay, definition of Newton. Newton is the unit of what? It's the unit of force. Okay, so what is the definition means? The amount of force required for a body. Okay, so the amount of force required for a body of mass 1 kilogram that produces an acceleration of 1 meter per second squared. Okay, so from the Newton's second law we know that F is equal to m into a. Okay, so the unit of force is Newton, and the unit of mass is kilogram, and the unit of acceleration is meter per second squared. Okay, or otherwise meters into second power minus 2. Okay, so definition of Newton means the amount of force. Okay, so the amount of force that is required for a body of mass 1 kilogram and acceleration. Okay, that mass of a body will produce an acceleration of 1 meter per second squared. Okay, so that is nothing but the 1 Newton. Okay, is the definition of Dyne. Okay, in the case of a SI system, the unit of force is Newton. In the case of a CGS system, the unit of force is Dyne. Okay, so what is the definition means? It's the amount of force that is required for a body of mass 1 gram, because in the case of a SI system, the unit of mass is kilogram. Okay, but whereas in the case of a CGS system, it's the CGS unit of mass is 1 gram. Okay, so that to produce an acceleration of 1, here the unit of acceleration is 1 centimeter second power minus 2. Okay, so like that definition of Newton, it's also from the Newton's second law, F is equal to m into a. Okay, so the amount of force, that force is nothing but 1 Dyne. Okay, so the amount of force required for a body of mass 1 gram that to produce an acceleration of 1 centimeter second power minus 2. Okay, so that is nothing but the Dyne. Okay, so the 1 Dyne is equal to 1 gram, because mass is 1 gram and acceleration is centimeter second power minus 2. Okay, and also 1 Newton is equal to how many Dyne means 10 to the power of plus 5 Dyne. Okay, Newton and Dyne are interrelated terms. Okay, so 1 Newton is equal to 10 to the power of 5 Dyne. Okay, so next one is what means unit of force. Okay, so the unit of force is nothing but the amount of the force that is required to produce an acceleration of 1 meter per second squared. Okay, so from the Newton's second law, the amount of force that is required to produce an acceleration is 1 meter second power minus 2 in a body of mass 1 kilogram. Okay, in a body of mass 1 kilogram. Okay, so that is nothing but the unit of force. Okay, so the amount of force that is required to produce an acceleration is this, and this will produce a mass of this. Okay, that is 1 kilogram. Okay, so this both are is nothing but the unit of force. One is gravitational unit of force. Okay, students, in the SI system, the gravitational unit of force is kilogram force. Okay, is nothing but the kilogram force, and it's denoted by, in shortly, this is denoted by kgf. Okay, whereas in the case of a CGS system, the gravitational unit of force is gram force, and this is denoted by shortly as gf. Okay, so from the Newton's second law, 1 kgf, okay, that is 1 kilogram force is equal to, because this is mass and this is acceleration. Okay, this is nothing but the force. Okay, so from the Newton's second law, mass is 1 kilogram into acceleration due to gravity. Okay, in 9th standard also you can study it. Okay, the small g, okay, the value of small g, that is acceleration due to gravity, is 9.8 meter second power minus 2. Okay, so substitute that value here. Okay, so that we can get 9.8 into 1 is equal to 9.8 Newton, because in the SI system the unit of force is Newton. Okay, whereas in the case of a CGS system, this is SI system, this is in CGS system. Okay, 1 gram force is equal to mass is 1 gram into acceleration is 980 centimeter second power minus 2. Okay, so that is equal to 980 Dyne, because in the case of CGS system the unit of force is Dyne. Okay, then next one is impulse. Okay, impulse means it's the short time of force. Okay, short time of force. So the definition of impulse is nothing but it's a large force. Okay, the impulse is a large force that acts for a very short interval of time. Okay, so a large force that is act for a very short interval of time is nothing but the impulsive force. Okay. Okay, what is the impulse? Impulse means it's a large force but acts in a very short interval of time. Okay, that is nothing but the impulsive force. So for this, first we consider a force. Okay, when a force F is acting on a body for a interval of time. Okay, first consider a one body, the force F is acting on that body for a time interval of t. Okay, then the product of the force and the time interval. Okay, product of the force and the time interval is nothing but the impulse. Okay, that is why we write J is equal to F cross T, because the product of force and the time interval is nothing but the impulse. Okay, that is denoted by capital J. Okay, so the SI unit of impulse is nothing but Newton into seconds. How? Because the SI unit of force is Newton and time is second. Okay, so the SI unit of impulse is Newton into second. Okay, by using of the Newton second law, okay, we have F is equal to change in momentum by time. Okay, change in momentum by time. So F is equal to change in momentum is nothing but del P, because it delta refers to the change. Okay, you have already studied in your maths class. Okay, so this delta change in momentum divided by time is nothing but the force according to the Newton's second law. Okay, so from this we have del P by T is equal to F. Okay, so from this we have to determine the change in momentum, means del P is equal to F cross T. Okay, so this is the equation 1 and this is the equation 2. So equation 2, this substitute in equation 1, so that we have J is equal to, instead of S we have, instead of F we have to put del P by T. Okay, into here also one T, so the T time and time will get cancelled, the remaining balance is the change in momentum. So J is equal to del P. Okay, change in the impulse is nothing but the change in momentum. Okay, already we know that what is the momentum. The definition of momentum is mass by volume. Okay, so P is equal to m by v. So the SI unit of impulse is otherwise. Okay, one is Newton into second and another one is for the momentum the unit is kilogram into meter second power minus 1. Okay, so del P is equal to, del P is del P, the SI unit of change in momentum is kilogram into meter second power minus 1. Okay, from this equation we can say that the impulse is also equal to the change in momentum. Okay, is also equal to the change in momentum. Which quantity? The impulse. Okay, so this change in momentum can be obtained, this change in momentum can be obtained in two ways. Okay, one is a larger force. Okay, on that body a larger force is applied, means the force act on a short period of time. Okay, so here the interval is very short. Okay, if we apply a smaller force, means that acts on a longer period of time. Okay, so by using these two ways we can change the momentum. Okay, so examples of the impulse means first one is automobiles are fitted with springs and shock absorbers, because it reduces the jerks. Okay, it's reduce the jerks while moving on the uneven roads. Okay, in second one is in cricket a fielder pulls back his hands while catching the ball, because of the he experiences a larger force for a shorter interval of time. By using this phenomena, okay, he experiences a larger force for a shorter interval of time. Okay, so that phenomena is known as leisure impulse. Okay. The next one is Newton's third law. Okay, already we have seen two laws. Okay, Newton first law and Newton's second law. Okay, so now we are going to learn about the Newton's third law. Okay, so the definition of Newton's third law is, already we know that what the definition: for every action there is an equal and opposite in opposite action. Okay, for every action there is an equal reaction and also in opposite reaction. Okay, that means equal in magnitude but opposite in direction. Okay, for every action there is an reaction. Okay, so that is equal in magnitude but opposite in direction. Okay, so they always act on two different bodies. So first we have to consider a body A and B. Okay, the force acting on a body A is Fa and the force acting on the body is Fb. Okay, so the force that act on the force Fb, that is act on a body A. Okay, and also the force Fa that acts on a body B. Okay, so that we can say what, for every action there is an equal and opposite reaction. Okay, so we get the equation as Fb is equal to minus of Fa, because these two are equal in magnitude. Magnitude means a numerical value starting from 0 to infinity. Okay, so equal in magnitude but opposite in direction. Okay, this will act in the north to south direction, means this force will act in the south to north direction. Okay, so example for the Newton's second law. First one is, when birds flies there. Okay, when bird flies, they push the air downwards with their wings. By using of the wings, a bird will downwards. Okay, a bird will downwards the air. Okay, so this is the action of the bird. Okay, so what is the reaction means, then the air pushes the bird upwards. Okay, the air it will pushes the bird upwards. Okay, so this is the reaction. Okay, students, this is the second example for the Newton's third law. Okay, what is that means, when a person swims, he pushes the water. Okay, when a person swims, he pushes the water backwards. Okay, using by the hands. Okay, so that is the action. So what is the reaction means, then the water pushes the swimmer in the forward direction. If we pushes the water backward, means the water will pushes ourselves to travel in the forward direction. Okay, so that is the reaction. Okay, students, thank you.